reading 21,000. Mechanically reading just under 500 bars, so 450 bars. Today we have an issue where this Isuzu truck has been running poorly, and it's throwing codes for low rail pressure too low, or rail pressure too high. It's kind of counterintuitive and it kind of contradictory, but what we have to do is figure out what it is and why it's doing it. So one of the issues that we ran into is when we're running, we have a desired rail pressure, right? And an actual rail pressure. Desired currently is 0 because it's off, and it says currently with the key on, it's at 21,664 PSI. Don't know if that's accurate while the engine's off, but if the engine's running, see it says 22,000 and it desires 5,000. When it's running though, this gauge is only at 450 PSI, or 500 bars, 450, which relatively equals 6,200 PSI. So I know it's not mechanically that high, it's electronically. Now that we have the fuel pressure gauge on and we can see that the physical mechanical pressure is not matching up with the electronic fuel pressure, now I need to verify why we have an incorrect electronic reading. So right now it says 13,670, key is on, and I don't know if it's going to update while the truck's not running. So I'm going to unplug the fuel pressure sensor, which is right here. Okay. And I'm going to take this plug and I'm going to look at the screen and it says 13,600. So my guess is that no, it does not update live, but let's actually crank it for a second and see what it says. So the reading of, laptop died. The reading of 36,000 is because if you unplug the fuel rail pressure sensor or the FPR, by the way, if you are physically getting 0 here and it won't start, you can always unplug the FPR right here, and then it'll default the pump into wide open throttle, which would be relatively 36,000 PSI. So if you unplug that and this goes shooting up, then that means that the computer is controlling that and telling it to defuel. So if you unplug that FPR to go straight to 36,000, we've ruled out supply, we've ruled out filters, we've ruled out the high pressure fuel pump, and we know that it's electronically commanding it to lose fuel. Now we got to figure out why. So the first thing we're going to do in this case is key on. We are going to take electrical probes and a voltmeter, and I am going to back probe these wires. I'm going to figure out which one's ground, which one's positive, and which one is returned to ECM. My guess is red is 5, green is ground, and white is returned to ECM. And we would know that by using the voltmeter, and I will show you how that works. So what I got is my voltmeter rigged up here. And we have right here, we have negative. Right here, we have positive. We have it set on DC voltage, okay? And what I need to do is I need to find 3 things. One, I need to identify the ground, the 5-volt constant from the ignition, or the 5-volt reference from the ECM. And then I need to find the return, which is the sensor output voltage, back to the ECM. So you might be asking, well, if I don't have a wiring diagram, how do I figure this out? Let me tell you, there's a really simple way you do this. First thing you're going to do is you're going to we're going to use these needle probes and back pin these, or back probe them is what you call it. So there's 2 things you're going to do. One, you're going to take a alligator clamp though, and you're going to pinch it straight to ground, anywhere that's good. That's metal, right up there. It doesn't matter, anything in metal. We're going to take the red, and I'm first going to find the easy one, which is 5-volt reference. And so if I go like this, you see on my voltmeter, I got 5. Let's go to the next one. I've got 5. And the next one, I've got nothing. So It's very weird. That's not supposed to do that. So here's what I'm going to do. I'm going to say that the white is 5 volt from the ECM. And because I don't have, you know, if I have 5 volts from the ECM and I have a ground and then I've got a 5 volt return to the ECM, if this is return, or for example, if this is ground, this is 5 volt positive from the ECM, this is ground, this should be return. Well, if this is return and I got 5 volts coming up it, that would explain why I've got a problem, is because the ECM seeing voltage all the time, which it shouldn't, which would tell me that something is touching or shorting. So here's what I'm going to do. I am going to first take, I'm going to assume that this is the 5 volt from the ECM. You see I got 5 volts, right? Now what I'll do is I'll take the ground side. I will take another needle. I need to trim this guy. Here, hold on a second. Now what I'll do is I will go like this, ta-da, right? And then I'm gonna back probe the other pins and see which one has ground. Because if I have ground and I'm positive, positive's on one pin, ground's on another. See, I've got no voltage, and then I've got voltage there. So that tells me there's our problem. This is our positive from the ECM. This is our ground to the frame through the ECM. And then I magically have, yeah, so that tells me that I either have a shorted wire in the harness somewhere touching, or I have a shorted ECM internally. Now, this is our engine harness plug. So then what are we looking at? We are looking at, that's really odd that they would do it this way, but the red right here, you can see we got red, green, and white. So we determined that red is our ground. This is theoretically shorted voltage, and this guy is reference. And I know this guy's reference because it's sitting steady at 5 exact. 5 exact is generally your reference voltage. So on the computer screen, it'll say 5 volt references. In this case, I'm going to assume that that is the correct voltage for the ECM reference. Now, the return wire should be dead, and it's not. So now I got to figure out why. So we're going to find the green wire. This is our ECM plug. And what I think I'm going to do in this case is I'm going to cut this ECM plug off. Not cut it off. Silly goose. I'm going to take this guy and I am going to unplug him, and I should see no voltage. There you go, no voltage. So now, what I need to do is determine if I have a shorted or corroded pin right here, or I have to figure out if it's on this end or the engine side, or if it's on the truck side. Let me look at a diagram for the ECM and see if I can't determine a pin out for the ECM. Now that I got my laptop plugged in, okay, here's what we got here. So here is a picture of the fuel rail pressure sensor, and it says that the red is low reference, green is FRP sensor signal, and white is 5 volt reference. So low reference would be negative or ground, however you want to word that. But the red is on the negative side. Green is FRP sensor signal, and white is the one that has 5-volt reference. So FRP sensor signal should be the one that reports back to the ECM. Now, here's a little bit of confusion. Here's a picture on the Isuzu IDS software. It's kind of right on the side of the motor. If I go back to previous here, here's our ECM flow. So as you see, we have our ECM up top, fuel rail pressure sensor down below, and you have your connection points. These are connection point, connection point, connection point. You have your red, which is ground. Sensor ground on red. Oops, there it is. Then you have green. So it looks like there's 2 pins on the ECM, and they are, that dot right there means that they're shared. So that's probably a 5-volt reference is sharing. This is the bail connector, which I'm guessing is right on the side of the frame rail that I unplugged. And then the other question I have is, this arrow right here, I want to make sure that it's not the flow of direction or directional flow. And what I want to do is try see if I can't find a, here's what we're going to do. We're going to go service manual, engine control systems, diagnostic information and procedures, descriptions and operations. I want to see a description in the service manual about how the fuel system description, let's do that. So fuel pressure sensor, right? I want to see it tell me, no, it's not going to tell me. I want it to tell me that the fuel pressure sensor is supposed to get number 3 sensor. Number 2 is a overpressure return line. So if that pops off, it'll dump excess pressure back. So fuel rail pressure, component description. So fuel rail pressure sensor. So fuel rail pressure is installed in the fuel rail, and it detects the fuel pressure in the fuel rail, converts the pressure into a voltage signal, and sends the signal to the ECM control module ECM. Higher fuel pressure provides higher fuel pressure sensor voltage, while lower provides lower pressure sensor voltage. The ECM calculates actual fuel rail pressure from the voltage signal and uses the results in fuel injection. Unfortunately, this is not telling me what I want, which is the theory of operation is we send a 5-volt reference down pin number whatever, we get a ground at pin number whatever, and the reaction of fuel pressure will send a variable voltage up wire number X back to the ECM. So all sensors that I know about, that's how they work. The pressure comes, how do we say this? The voltage, you remember there was 3 pins, 1, 2, 3. Power comes in, ground comes in, and then as you get power voltage change this way because the spring diaphragm in the center, or the spring assembly, is being pushed, the plunger, and that changes the voltage that comes out of the sensor, and that would go back to the ECM. So my assumption is the output should be 0 with it unplugged, and it should be 5 volts with it plugged in and max rail pressure, or it should be 2.1 when it's idling or whatever. But let me see if I can't find a service manual description that says, when testing, check this. So repair instructions. Fuel rail pressure. Step 1, remove fuel rail pressure limiter. Step 2, remove fuel rail pressure sensor. Oh my goodness. It's about as basic as it gets, huh? So these are not going to tell you how to diagnose it. So let me go back again. Let me go back and try symptoms on engine control. Let's go there. Here you go. This actually answers something that we were talking about earlier. Inspect the sensors for engine control following conditions. Refer to scan data list. Use a scan tool to observe the actual fuel rail pressure parameter. With the engine off, actual fuel rail parameter should be less than 441 psi. If after the ignition is cycled, if not, check for high resistance in the 5-volt reference circuit, low reference circuit in signal circuits, or skewed sensor. Use the scan tool to observe actual FRP and desired parameters at idle and fully accelerating. User parameters should always be within 1400 psi of each other. So that would tell us that the fuel rail pressure with the key off was not less than 441. It was, 8,000, 9,000, 13,000. These are really generic diagnostic things, and so don't hang out too long watching this video if you're getting kind of bored with this, because I have to do a little bit of thinking as I'm trying to teach you guys how to find the correct answer. But moral of the story is, so far all I have is I think the most damning evidence here is we have we're going to go electrical schematics, we're going to go schematics, engine controls, fuel controls, fuel rail pressure sensor. So at the ECM, you're going to have B13, B25, B26, B47. So if we go here and we've got our ECM plug here, if you want, you can pause the video and look at the numbers and the pin layout as I'm going. This might help you out. ECM is located right behind the dump bed, or under the dump bed, right behind the transmission. Let's go look at that. One of the things I could do in this case is to verify if it's an ECM or not. I can go to the ECM, right? Unplug the big plug. Whoops. Unplug the big plug right there, and then check continuity between here and the engine harness at the sensor, and I can verify which wire it is, and I could go over here and I could cut that wire, and if there's literally nothing connected between the tip of that wire and that plug and there's still voltage coming out, then that would tell me that it is in the ECM itself. So that's what we should do. The video was correct. The ECM is right here. So this guy's part number, by the way, 897-381-2450. Here is your plugs. And now what we're gonna do is we are going to kind of look at these plugs and try to figure out which is which. There are no number markings on it that I can see. I think there's a plug A and a plug B. This looks like the plug B that we were looking at on the computer screen. I will go verify. Let me go look. So now looking at the computer, we have our B54321, right? And then we have the same over there. So I know that this little plug, not the big plug that we're looking for, they're engine control. The other one's probably other stuff like module, multi-module communication, all that kind of stuff. But this is the engine control side of things. Now, we are looking for B, I think it was 47, right? Let's see if we can get this guy. B47. Fuel rail sensor 5-volt reference. So red is 5 reference, and then green B2425 is sensor signal, and then red is low. So red is low. White is high. I need to write this down. Red is low, white is high, green is return. Okay, so let's go plug it in and see what we got. So we have a crazy conundrum here. And here's what we did. I'm trying to test continuity. If you don't know what continuity is, that means that this pin to this pin, if you touch the two leads together on your voltmeter, you'll get a buzzing noise, right? So check this out. I have the pin B26 on the smaller plug. So if you look at it just right, you have your stack of 6 over here, and then it's the second row up, and then you go 1, it's 19, 20, 21, 22, 23, 24, 25. 25 or 26. And what I'm doing is I'm testing continuity through this harness all the way up to this plug. Now check this out. Theoretically, it's this green wire right there. If I go through this end of the plug, I get nothing. If I go through this end of the plug, I get my beeps, which means that for some reason, this pin is either not working, because check this out. If I unplug it and I go into this end, sorry for the noise guys, into this pin right here that works. So that tells me that there's something wrong with this pin right here, and I gotta figure out why. Bear with me as I try to show you this. We have our green wire here, goes through the engine harness, goes to this plug, and then it goes to this plug, and then it comes out the back, right? So here's an interesting thing. From here to here, I have one connection, this joint, and then I have the harness. I've got no continuity. But if I take my voltmeter and I go directly to this point, I got continuity, right? So I verified the tool works, I verified the circuit works, right? Then I go to the green wire on here and I got continuity. Go to the other one, I've got continuity. But if I go to the other side of the plug, I've got nothing. If I unplug this guy, I go here, I got continuity, I got continuity. Okay, so then if I plug this guy in, like that, I should have continuity because the male and female tips are touching each other. I got nothing. But check this out. If I unplug this guy and I go to here and I go to here, I got continuity. So these two halves are not contacting each other correctly, and therefore it's giving it a crappy signal. So one of the things that I could do in this case is take this 2-wire junction here and cut it here and cut it here. See if you can see that. Cut it back here, cut it here, and then join these two together. And if I've got continuity, then that would take me continuity all the way to here, and that would tell me that there's a pin connection issue right there. What I did here was I took that green, I said we got a broken connection some reason in this plug, right? So I took the green on one side and I skinned it. As you can see, I kind of skinned it with a knife to expose the copper. And then I did the same thing on the other side. And now I have continuity from this side of the plug. As you can see, I have continuity from this side of the plug all the way to that. So now what I'm gonna do is I'm gonna put the ECM back in, and I'm going to, actually what I could do is I can go like that, right? So there's my sensor plug, and I'm gonna unplug at this one. So I'm on this side of the plug. I'm gonna go all the way to the ECM and see if I got a signal now, which I know I do. There you go. So now what we'll do, see, and this is the reason why you gotta do these kind of things. As much as this sucks, like this whole thing's been a nightmare, but check this out. Now I can save the customer $2,000 ECM and more downtime. So what I'm gonna do is I'm gonna plug this guy back in. And actually I'm gonna get the big plug in first. That's what she said. There it is. There you go. Right? Now what I'll do is I'm gonna plug the sensor back in here. And I'm gonna turn the key on, and I'm gonna look at actually what is the voltage reading coming out of the ECM. So I'll go like this. I'll go green because that was my sensor signal back to ECM, correct? Oh, come on. Now you don't want to go in there, you asshole? Come on. Ugh. Okay, so I bypassed that plug with the jumper, and I may have a continuity. Oh, hold on a second. Goofy goober, dude. Anyway. Alrighty, ladies and gentlemen. So, would you look at that? The actual fuel rail pressure is reading correctly now. And it turns out that the problem is because that cam lock was broken, the pins were not seating correctly. So sometimes I would squeeze the connector like this and I would hear the electronics on the engine intermittently cut in and out. And now I'm reading correctly. So if I clear my codes, no current codes. And then if we go to scan tool, data display, our fuel pressure readings are accurate. So all of this bullshit, because this connector was zip tied together. Goddamn. And so this is what your idle voltage should be, not 5 volts. 5 volts is because there was a broken connection and it just defaults to 1.68. Well, ladies and gentlemen, no check engine light. Sorry, my computer died again, so I can't show you, but it's all running smooth as silk again. So moral of the story is this bail connector would not contact the pins correctly, and then the ECM would default to 5 volts because it's like, I don't know what's going on, so I'm just gonna throw a number out, and it was the wrong one. So I guess next I gotta test drive it, but I could verify, as you saw in the video, it had connection, it didn't have connection, I bypassed it, I could make continuity, I got all the connector back together, and then I had continuity all again, and there you go. What a crapshoot.